Large objects cannot be printed as a whole. We first need to decompose it into smaller 3D parts. Common approaches that connect printed 3D parts by glue or by small connectors have various shortcomings. See paper. This work proposes a novel solution that constructs printable 3D parts with 3D interlocking property. By this, we can overcome the shortcomings with glue and small connectors and achieve stable object assembly. Part 1. Comparison with Song et al. 2012. Song et al. 2012, which is the state-of-the-art method for generating 3D interlocking structures, is insufficient for generating 3D printing parts. First, they randomly arrange cutting seams on object surface. Some of them could be on salient object regions, which could be rather distracting. Second, their parts could be disconnected and cannot be printed. Third, it could produce parts with weak and fragile connections. Part 2. Pipeline Overview. We take a general watertight mesh model as input and perform voxelization on it. However, local shape within some partial voxels could be tiny or disconnected, which complicates shape partitioning. Hence, we perform local and minor deformation on the model to avoid tiny voxels and resolve disconnected voxels. Until there are no undesired voxels in the voxelization, then we identify internal voxels in the voxelized model and build connection graph for the boundary voxels. Taking all the internal voxels as input, we generate an initial set of 3D interlocking parts. Guided by the connection graph, the boundary voxels are attached to the initial parts, fulfilling the fabrication requirements. Lastly, parts geometry are obtained by CSG intersection. Parts from our method are structurally strong for 3D printing. By interlocking, the assembled object is steady and solid. Part 3. Results. Our method can create interlocking parts from 3D models with a variety of shapes. Our generated parts are structurally sound and are strongly connected by interlocking upon the assembly. We also apply our method to create an interlocking ring. The key part is specially designed. We need to lift it up by a short distance before being able to take it out. Part 4. Fabrication examples. 10-part face model. Ten-part Max Planck model. Two-part ring model. Six-part duck model.